All right, let's continue on with example 2 from our textbook. In the last video, we graphed everything and we saw this curved line. Now let's answer the questions that they're asking us. So at first, they ask us to compare the stopping distance when a car is traveling at 30 kilometers per hour to that when it's traveling at 50 kilometers per hour. Well, this is a value. We need to find those values. So I'm going to go second function, calculate, and let's find the stopping distance at 30 kilometers per hour. And here it is at 13.2. Let's write that one down here. 13.2. Okay. Now let's try another value. Let's try 50 kilometers per hour. And that is 37.3. Don't know if you can see those very well. So if we compare those two, we're not trying to add them or subtracting. If we compare them, we're seeing that it's almost 3 times as much distance required when we go from 30 kilometers per hour to 50 kilometers per hour. All right, the next question is a little bit different. The next question asks us to find the stopping distance that would be, or the maximum speed that would give us a stopping distance of 4 meters, which is about the length of the average car. So this one is quite different, actually. We want to find a y value. Second function, calculate, gives us x values. These are x values. We don't have something here that will tell us a y value. So I'm going to go to y equals. There's a whole bunch of y's, right? It's y equals. So let's put in this other y value that we're looking for. I'm going to put y equal to 4. Now, if I graph this, the line is going to go in there. It's just very hard to see because of our window. So let's go change our window again. Notice x values don't even go as low as 4. So we're not going to see it. So let's make this a little lower. Let's go, sorry, these are x values. Let's go to negative, let's set that to 0. I'm going to make this at negative 15, so we have our y value in here. I'm going to change the scale. I'm going to go up by tens, so we can maybe see a little bit more of our graph. Not really seeing that yet. And this is trial and error with our graphs. Okay, we don't need a whole lot of this upper stuff, so maybe I'll trim that down a bit. Let's go to a maximum of 20. And now we can see there was our original data in the graph. We don't need all this information that was up here. What we do need is this line here, so we can see both our line of best fit and this straight line. Well, we want to find out where they intersect. Second function, calculate. I'm going to find an intersection point. Hit enter. Now it asks for the first curve. We've done things where it asks for the boundaries. This is asking for the first curve. And there is our curved line that we had before. So that is one that we want. So I'm going to hit enter. Now, there's the cursor. It's telling us for the second curve, and it gives us y equals 4. That is the second line. So I'm going to hit enter again. Now, like before, it asks for a guess. We don't need to guess, but if we want, we can scroll down close to where that intersection will be and hit enter. It does its calculation, and it finds the intersection point. When y is equal to 4, which is our stopping distance, it tells us that x, our speed, should be about 20.4 kilometers per hour. Okay, so take a look at example 3 in your textbook. You can read through that one. I'm not going to go through it here. What you should see, though, is your data starts to form a cubic regression. And if you go to second function, calculate, and you go down to number 6, you will see a cubic regression. And we can go through the same process to find this equation. All right, now it's time for some practice again.